Good morning. Our dear viewers, good morning. It has been long since last week. But finally we are back. I want to begin by thanking God that we are still alive. Though most of us are somehow disappointed in life. But you shouldn't be disappointed, because you still have the greatest treasure. And the greatest treasure is life. We are still alive. Some of us and some of our friends would have wished to be alive, but they cannot. So let us be grateful to God that we are still alive. And yesterday I was listening to the gospel by some pastor. And he said something that touched me a lot, that the pandemic came for some of us to learn. All of us were living in a life whereby we knew that things were just okay. All of us thought that things would come back to normal after 1 month. But now it's coming to 4 months. What does that mean? We need to think otherwise. Whatever profession you're doing, you must have a side income or a side job. Because what I know and what I've gotten to learn, that all of us have been affected. All of us have been affected. So we need to think otherwise. Even the students, even the pupils, they have been affected. Because none of us had ever seen such a pandemic. We were told, but none of us had ever seen such. So we need to think otherwise. We are still looking at chlorine and its compounds, and we had done some bit of the chemical, and we had done the physical properties. But what must I say? I left you with some numbers. Which numbers? Some of you tried, some of you never tried. Please try out. Don't lose hope. We are very hopeful. We are very hopeful tomorrow. And whatever our dear president will say, we'll mark it all. So let us be very hopeful. Don't lose the guts. Some of you have lost the guts of doing work. You've been told this is a dead year, so studies will resume next year. Please, even if studies are to resume a year after next year, we shall resume. So please continue doing the work. Continue revising, continue doing the housework also. You never know. So, I left you with some numbers, and the number that I left you with was a number on mole concept, because there are very many numbers, there are very many questions on mole concept. You can never finish them. And every year, and every time a number on mole concept is examined, there is something small they're looking out for. So, let us look at the number that I left you with, and I will continue with some of the chemical properties of chlorine. God willing, we might finish them today, or if we don't finish them today, then it will be next time. I left you with number one, and number one, what was number one saying? Number one was saying that 4.3 liters of what? Of HCl, that is hydrogen chloride gas, was bubbled through, okay, 700 centimeters cubed of 1 molar silver nitrate solution. Okay? And they said all this was at room All that was carried out at room temperature. What was the first question about this number? The first question was calculate the number of moles of HCl gas that was bubbled. And I told you all what we studied in mole concept will be very vital, because there are times whereby the questions are set and the questions need you to remember some bit of mole concept, some part in mole concept. Here they're asking for the number of moles of HCl that were bubbled, but they've given you 4.3 liters and they've given you a hint. All this was done at room temperature. Remember, HCl, that is hydrogen chloride gas, is a gas. And remember, what did we talk about molar gas volumes? We said whatever the gas, at STP, it will occupy a particular volume. Even at room temperature, it will also occupy a particular volume. Okay, so what does that mean? What does that mean? We had to remember that 1 mole of hydrogen chloride gas, okay, what does it occupy? It occupies 24 liters. Why have I used liters instead of decimeters or instead of centimeters cubed? Because even what I was given was in what? In liters. Okay? So I remember I told you you are using first principles, and whenever you're using first principles, what you're calculating for, what you're looking for, should be on your right-hand side. What you have should be on your left-hand side. Therefore, we shall say 24 liters of hydrogen chloride gas contain 1 mole. This is the same as the first statement. Then we shall ask ourselves, we are using first principles, what about the 4.3 liters of HCl? Will contain 1 mole over 24 liters times what? Times the 4.3 liters. And what do you get? Okay, what do you get? You get 0.1792 moles. I've taken it to 4 decimal places to reduce on the errors. So those were the number of moles of hydrogen chloride gas that were bubbled into a solution of silver nitrate. And it needed you to remember the other concept of molar gas volumes. Then the part B of that number was to calculate the number of moles of silver nitrate the number of moles of silver nitrate in that silver nitrate solution. But remember, what were we given? We were given this. Therefore, what do? We shall say 1,000 centimeters cubed of silver nitrate solution contain 1 mole, contain 1 mole, because it was 1 molar. What about 1 centimeter cubed of silver nitrate solution. It will contain 1 mole over 1,000 centimeters cubed of silver nitrate. So what about the 700 centimeters cubed? The 700 centimeters cubed of silver nitrate solution will contain 1 mole over 1,000 centimeters cubed times what? 700 centimeters cubed of silver nitrate, And therefore, what do we get? You can use your calculator, but it would come out quickly. But please, always use your machine. And what do you get? You get 0.7 moles of silver nitrate. Okay? And I think that is what you got. For some of you, tried it out. Let us go to the last part of that question. The last part of that question was asking for the mass of silver chloride that was formed. The mass of silver chloride that was formed. Mass of silver chloride that was formed okay, and they gave you the relative atomic mass of silver to be that, and that of chlorine to be 35.5. There is no way you would proceed with this question. There's no way you would proceed with this question before you're writing the chemical equation. That's why I told you all the numbers that we are going to look at in mole concept. Most of the numbers will necessitate you to know, to have that basics of chemical equations, chemical symbols, balancing chemical equations. That is senior 1 work. Therefore, we shall write our equation for the reaction. Our equation okay, we had HCl, which was a gas, and what it was bubbled through silver nitrate solution. And what did we get? We got silver chloride plus what? Plus nitric acid. Okay, that is our equation for the reaction. And what are we seeing from our equation for the reaction? We are seeing that basically the mole ratio or the reaction ratio of the reactants to the products is 1:1. Therefore, what are we seeing? We are seeing that 1 mole of HCl reacts with 1 mole of silver nitrate to give us 1 mole of silver chloride plus 1 mole of nitric acid. That is what we are seeing. And the question, what does the question want? The question wants the mass of silver chloride, that was formed. Therefore, what shall we do? We shall look for the molar mass of silver chloride. And a bright student would ask me, Madam, now why are you looking for molar mass of silver nitrate? Because molar mass from that word molar mass, we have a relationship between mass and moles. And from our equation, we have also seen that 1 mole of HCl reacts with 1 mole of silver nitrate to form 1 mole of silver chloride. Therefore, it will be 1 times silver plus what? Plus 1 times chlorine, which is 1 times 108 plus 1 times 35.5, which is giving us what? It is giving us 143.5. Yeah, I think that is 143. 143. Please, if you're not very sure, use your machine. And the machine I'm talking about is your calculator. So that is what we have gotten. And we have looked for molar mass simply because molar mass has that relationship of moles and then grams, which we are looking for. But from our equation, what are we seeing? From our equation, what are we seeing? We are seeing that 1 mole reacts with 1 mole and 1 mole to form 1 mole of silver nitrate and 1 mole of nitric acid. But remember, what were the number of moles that we got? The number of moles of HCl were 0.172 moles. What about the number of moles of silver nitrate, which was also among our reactants? It was 0.07 moles. And this is where you have to be very sober. Okay? Here, the reaction ratio is 1 to 1, 1, giving us 1, giving us 1. Okay, what does that mean? You're having this, you're having this. The number of moles are not the same. What does that mean? What does that mean? That when you bubbled HCl through this solution, you formed this. Okay? You would expect the number of moles here to be the same, but the number of moles are not the same. Okay, what does that mean? When you bubbled HCl through this, that solution that you used, it means that there is a possibility that all its moles did not react. Okay, therefore, what do we look out for? We now take the smallest number of moles. We shall take 0.1792 moles instead of 0.7. Though you got 0.7 in that solution, it means that not all the 0.7 moles did what? Reacted. Out of the 0.7, only this reacted, because from our equation is 1 to 1. We looked at this when we were looking at somewhere Gay-Lussa's law, but that was in volumes. So it means that from our equation, the number of moles must be the same, since it is 1 to 1. But from what we have calculated, the number of moles are not the same. It means that these were number of moles that were in excess, and therefore it means that out of the 0.7, only this reacted. Therefore, the remainder of about 4 point something did not react. So what does that mean? The number of moles of silver chloride that reacted will be gotten from the smallest number of moles, because we have seen, though you bubbled it through that solution, not all the moles in that solution did what? Reacted. Okay? Therefore, the number of moles of silver chloride will be what? Will be 0.172 moles. Instead of this, it means that though we had 0.7, out of the 0.7, only this did what? Reacted. It means that the rest remained unreacted. Therefore, we shall say 1 mole of silver chloride weighs what? Weighs, what have we gotten? 143.5 grams. And thereafter, what about the 0.179 moles? Will weigh 143.5 grams over 1 mole times what? Times the 0.179 moles. And you get your answer in grams, which we are looking for. So it will be times the 0.1792. And what do you get? You get grams. Those were the grams that were formed for silver chloride. Why did I give this question? There's a student who sent it to me, and the student was scared. The student told me, madam, but the reaction ratio is 1:1, but the number of moles are not the same. There you have to go back and think otherwise. Though all those number of moles were present, it means some remained unreacted. That's why we use the smallest number of moles among the reactants to relate them to the product that was formed. It means that if the question had wanted the number of moles of silver nitrate that were unreacted, it means that you would get 0.7 minus 0.1792 moles. Have you gotten that? So that is what the question wanted, because from our equation it was 1:1. Therefore, the number of moles had to be the same. But it means that these ones that were 0.7, some were unreacted. Some did not take part in the reaction. So that is what the question wanted. And I know now you've gotten that. Please, you look out for other numbers. Okay, I will not look at number 2, because number two of the questions that I left you with, I had already discussed it. I already discussed it among reaction of chlorine with metals. I had given you magnesium to write the equation and to state the conditions. The conditions were very simple. You needed only to heat, and chlorine was supposed to be dry. So those were the conditions. But the equation I had given that in the work that I had given. So let us continue with some of the reactions of chlorine gas. And today we are going to look at reaction of chlorine gas with alkalis. Reaction with alkalis. And before we proceed with alkalis, we must understand very well what is an alkali. An alkali is a soluble base. And remember, that is also from senior 1, a base, acids. We said, what is an acid? It's a proton donor. What is a base? It is a proton acceptor. And we said some bases are not soluble in water. Some bases are soluble in water. Those that are soluble in water are called alkalis. And I remember we gave you around 3 of them. We gave you ammonium hydroxide, okay? We gave you potassium hydroxide, and also your teachers gave you sodium hydroxide as some of the examples of alkalis. But for us here, we are going to concentrate on basically on the 2. Those are the strong alkalis, and that is, we shall look at sodium hydroxide and then potassium hydroxide. How does chlorine react with these alkalis? Okay, with either potassium hydroxide or sodium hydroxide. Remember that all those bases are all gotten from metals that are in group 1. Therefore, you expect the chemical reactions to be similar. So instead of giving you sodium hydroxide, they may give you potassium hydroxide. And the chemical reactions and the observations are going to be the same. Though the vigor of the reactions may not be the same, but the chemical reactions are going to be the same. So reaction of chlorine with alkalis. I'm going to use potassium or I'll use sodium. But whenever the question has been treated, for you must know that the similar chemical reactions take place. So when chlorine is reacting with alkalis, it is in 2 different formats. Whether the alkali is cold and dilute, or whether the alkali is concentrated and hot. So whenever you're looking at this reaction, that is what must come in your mind. Is the alkali cold and dilute, or is the alkali concentrated and hot? Sometimes instead of using the word cold and dilute, they will use the word aqueous. Aqueous potassium hydroxide, aqueous sodium hydroxide. So you must remember that, because whenever the question has been set, if it is in paper 2 and it is structured, they will be very specific, whether it was cold and dilute or it was hot and concentrated. Sometimes it may come still in paper 2, but in section B. But this time around, they will say, discuss the reactions of chlorine with the sodium hydroxide. And still, you must also be very keen and you tell the examiner, under what conditions? Is the alkali cold and dilute? Is the alkali hot and concentrated? Therefore, with cold and dilute, alkali. Which alkali I'm talking about, we are going to use either sodium hydroxide, or we shall use also potassium hydroxide solution. What is the examiner interested in? If the examiner stated for you it is cold and dilute, it means that the possible questions are going to be state what was observed, and the next question is going to be write the equation for the reaction. So when chlorine or bromine, in that format, chlorine or bromine, their chemical properties tend to be similar. When chlorine or bromine is reacted with that, but here we are looking at chlorine. Remember also, instead of chlorine, they might bring for you bromine. So when chlorine is reacted with, or when chlorine is bubbled through a cold and dilute alkali, which may be potassium hydroxide or sodium hydroxide, what do you observe? You observe, your observation should be okay. Remember, these alkalis in solution form, they are colorless solutions. Therefore, what do you observe? You observe that the colorless solution turns to a pale yellow solution. And I always tell my students, please, when it comes to observations, unless you're sure of what you're talking about, please, in observations, we are only interested in the color and the state. Okay? Some of you go further and say, the colorless solution of this. And in mentioning what the colorless solution is, you mention something that is wrong. Only mention what the color and the state of that solution is if you're sure of the chemical name or if you're sure of what you're talking about. Here, a student may say a colorless solution turns to a pale yellow solution of sodium hydroxide, which is wrong. So when it comes to observations, please only talk of the color and the state. But if you're sure of what you're talking about, you may also go further and tell us that a pale yellow solution of sodium chlorate 1. It means that you're sure of what you're talking about. But if you're not sure, please only end at saying, talking about the color and the state. So whenever chlorine is reacted, is bubbled through a cold or an aqueous solution of sodium hydroxide or potassium hydroxide, you're expected to form a corresponding halide and a corresponding halate 1, and then water. It is that halate 1 that makes that solution to turn to a pale yellow solution. Therefore, what are our products? Our products, we shall form a halide. Okay? We shall also form a halate 1, and then we shall also form water. And since the question was state what was observed, if you only name the name the halide, and then water, you will not score any mark, because we have said in observations, what do we talk about? We talk of the color and the state. That's why I only said a colorless solution turns to a pale yellow solution, and you'll score your marks. So for you, what must you remember? If it is chlorine, or if the next time they don't ask about chlorine, they ask about bromine, being bubbled through an aqueous solution or a cold and dilute solution of sodium hydroxide or potassium hydroxide, what do you observe? What do you form? You form a halide, a halate 1, and then water. Therefore, when these questions are set, they may ask for conditions, they may ask for observations, they may also go further to ask for the equation. Okay? So, the conditions are here, cold and dilute. I've told you, instead of using the word cold and dilute, they may use the word aqueous. The observations are here. Whether it is potassium hydroxide or sodium hydroxide, you still have the same observation, which is a colorless solution turns to a pale yellow solution. What will be our equation? Our equation okay, we shall have our chlorine gas being bubbled through an aqueous solution of sodium hydroxide, okay, to give us what? What is our responding halide? That is sodium chloride, which is aqueous, plus our halate, which is sodium chlorate 1, plus our water. So this is our halide, this is our halate, this is our water. Those are the products you form. This is aqueous, this is aqueous, this is a liquid. And I told you, even if your symbols are neatly written and correctly written, and you also have your state symbols correctly written there, if the equation is not balanced, you would have wasted your time. Therefore, let us try to balance our equation. We have 2 chlorine atoms. We also have how many? 2. Sodium atoms, how many do we have? We have 1, 2. But on this side here, we have only. Therefore, we multiply this side with a 2. Oxygen atoms, how many do we have? We have 1, 2. And our hydrogen atoms, how many do we have? We have 2. Therefore, our equation is balanced. When you will be practicing at home, you try out for bromine. You also try out what would happen, how will the equation look like if that given you potassium hydroxide. That will form part of your assignment. Instead of using sodium hydroxide, please, you can use potassium hydroxide. Okay? So that is what you observe. That is your equation, and your observation is here. Therefore, this is our sodium chlorate 1. Okay? If it was potassium, it would also be potassium chlorate 1. Okay. So that is when they have used cold and dilute. We have looked at the conditions, we have looked at the observation, and then we have looked at the equation. Please note that I've told you, instead of using the word cold and dilute, they may use the word aqueous. Okay? And I told you, if it has come in paper 2, but part A, section A, they may say this chlorine was bubbled through aqueous sodium hydroxide. State what was observed, write the equation. If it comes in paper 2, but in section B, it may come whereby they will say chlorine was bubbled through sodium hydroxide solution. Okay? State the observations and then write the equations. It means that you must be very specific. When cold and dilute, or when hot and concentrated. I think that point has been taken. So let us look at part B of that reaction, when the alkali is hot and concentrated. So let us look at that part. When it is hot, it means that some heating is what? Required. Still, we are using the same alkalis. We can use potassium, we can use sodium hydroxide. And the obvious question would be, state what was observed. What do you observe? Here you simply observe a colorless solution. When you bubble chlorine gas through that hot and concentrated, it will not turn to a pale yellow solution. It will remain a colorless solution. Therefore, your observation will be a colorless solution. A colorless solution. Remember, for aqueous, we said you observe that the colorless solution, because those alkalis are colorless solutions, they will change to a pale yellow solution. Here you simply observe a colorless solution. It means that there was no observable change. Remember, no observable change is allowed in chemistry, but in biology it's not allowed. Therefore, what will be the next part if such a question was to come? They will ask for observation. Remember here they've already mentioned the conditions. Therefore, they will not ask you the conditions. The conditions should be the alkali should be concentrated and hot. So what is going to be the possible question here? The possible question is going to be, write the equation. And for us, we are not interested in the word equation. Therefore, what do you form when chlorine gas is bubbled through a hot and concentrated sodium hydroxide or potassium hydroxide? What do you form? You're going to form a corresponding halide, like for aqueous, okay? You also form a corresponding halate. By this time round, our halate is halate 5, okay? And you'll also form water. The other time we formed halate 1, here we are forming halate 5. For some of us who are going to continue with chemistry at A level, we shall see why are we calling them halate 5, why are we calling them halate 1, okay? It's because of the different oxidation states of chlorine in those atoms. So what will be our equation? Our equation is going to be we have our chlorine being reacted. This time around, let me use potassium hydroxide. To give me what? To give me a corresponding halide, which is potassium chloride. Remember, all chlorides are soluble apart from the few silver, lead, and so on. Plus our potassium chlorate, which we basically talk of potassium chlorate, plus our water. This is a liquid, this is aqueous. Okay? Remember, potassium chlorate is a white solid, but when you dissolve it in water, it forms a colorless solution. Therefore, let us try to look at our equation. Our symbols are correctly written, they're neatly written, but now let us see. We need to balance our equation. Okay? And I remember I told you guys that please, whenever you're writing these chemical equations, make sure that you write them on one line. Okay? Some of you tend to write the reactants this side, the products here. But when it comes to, again, to the products, because there are some products that did not fit on the line, you come and write them this side. It will be very wrong. Please try to write your chemical equations so that the reactants and the products fit on one line. So let us try to balance the equation. How are you going to balance the equation? We have how many? We have 2 chlorine atoms this side. Here we have also 2. We have 2 potassium. We have 1 potassium, but this side here we have how many? 2. You begin by saying, let me put a 2 here. When you put a 2 here, it means that the potassium atoms have also balanced. But the oxygen atoms, how many do we have? We have 2. But this side here, how many do we have? We have 4. Therefore, when you put a 4 here, it means that what has happened? The potassiums have become how many? 4. The oxygen atoms have become how many? They have become 4. The oxygen atoms have become 4. Oxygen has balanced this side. But the potassiums have not balanced. Therefore, when I multiply with a 2, I also multiply with a 2. It means that now I've again affected the chlorine atoms. I've also affected the oxygen atoms. Therefore, it means that now my 4 here does not work. Even the 2 here will not work. I started with a 2. I went to a 4. Let me go now to the next number. Let me put here a 6. When I put here a 6, it means that the potassium atoms have become 6. Okay? The oxygen atoms have become 6. Here I have 3. Therefore, when I multiply with a 3, it means that the oxygen atoms are 6. The hydrogen atoms have become 6. Even this side here, I have how many? 6. Okay? But what has happened? The potassiums have become how many? 6. Therefore, I multiply with a what? A 5. So that now the potassium, I have 5 plus 1, 6. The chlorine atoms have become how many? 5 plus 1, they have become how many? 6. Therefore, I multiply with a 6. Sorry, with a 3. And my equation will be balanced. So that is a general equation. When chlorine is bubbled through hot and concentrated alkali. I told you they can use potassium, they can use sodium hydroxide. Okay? I've given you the observation. I've talked about the conditions. What are the conditions? Our alkali must be hot and concentrated. So you look out for those questions. If they have come in paper 2, is it in section A? Is it in section B? And these same questions will still apply for guys that are going to continue with chemistry at A level. The chemistry sciences don't change, so you will still meet the same equations. So that was a reaction of chlorine with alkalis. And I began by defining what an alkali is. I've given examples, and I've told you the alkalis that we use here. We use the strong alkalis, and our strong alkalis are 2. We have our potassium hydroxide. We are also talking of our sodium hydroxide. Okay? So that is our first reaction today. So our next reaction is going to be the displacement reactions of chlorine. The displacement reactions are very important, and when you look at displacement reactions of chlorine. Before you look at the displacement reactions of chlorine, you must also understand what is a displacement reaction. Okay? A displacement reaction is a type of a reaction whereby either a more negative or a more positive element takes the position of another element in a given compound. It means that one element is displacing another element. And for you to displace another element from its compound, it means that you must be more reactive than it. If you're a metal, it means that you must be more electropositive than it. If you're a non-metal, it means that you must be more electronegative than it. And we shall get all that from what we term as our electrochemical series. I remember when I was introducing chlorine and this compound, I gave you that the chlorine is a member in group 7. And when you look at chlorine, we start with the fluorine. We shall have our chlorine. We shall have our bromine. And then we shall have our iodine. And I told you, when it comes to reactivity decreases down the group. What does that mean? Fluorine is more electronegative than chlorine. Chlorine is more electronegative than bromine, and also more electronegative than iodine. What does that mean? That in terms of reactivity, chlorine can displace bromine from its compound. Chlorine can also displace iodine from its compound because it is more electronegative. So these questions are also very common. These questions are also very common. So with the displacement reactions, time is not on my side. With the displacement reactions, you must know what a displacement reaction is. It is a type of a reaction whereby a more reactive element displaces another element from its compound. And I told you the element can be a metal or it can be a non-metal. And if it is a metal, it means that a more electropositive element displaces another. If it is a non-metal like for chlorine, it means that a more electronegative displaces a less electronegative. So with the displacement reactions, we shall basically need this concept. The reactivity of members in group 7. And that is what we have seen. Reactivity decreases down the group. We shall see how are these questions set. I told you time is not on my side, and I will wind up the I will give a question on displacement reaction, and then we shall start from that. So our only question is going to be state the observation and write the equation for the reaction that takes place when when chlorine gas was bubbled through a solution of potassium iodide. And the other part would be part B. Explain your observation. Explain your observation. Okay? Time can never be enough. Time can never be enough. Time can never be enough.